When Vue 3 was first released, the Vue team made us a promise that we were going to be able to organize our code by logical concern with the help of the composition API. And that promise was accompanied with super cool screenshots like these ones, where we'd see an options API component and then the refactored version of it in the composition API. And you can see from the color coding by logical concern that all the sections move into neat, nice, discrete categories. And this is definitely possible. This is good, solid proof that this is indeed possible. But in my experience, it doesn't quite come for free. There's definitely a risk when you're using the composition API. You could end up with something closer to this one in the middle, this component here in the middle, where it is written with composition API, but it's organized as if it were still under the constraints of the options API. So all the data is defined first, then methods, and then watchers and lifecycle hooks and things like that. So that's the way that I first started writing composition API components. I think there are downsides there just because it's so easy to come back later on and break that organization strategy and just add more code at the bottom for a new feature, that you end up with these long, big components that are kind of inconsistent and hard to predict, and it's difficult to know where exactly the code is that you're trying to find. So today I want to talk more about logical concerns in general. I'm Alex Vipond. That's a nice, flattering picture of me in some random basement. I'm a front-end developer at a data viz company called Kumu, and I also work on an open source project called Baliata. It's just a big toolkit with lots of Vue composition functions and components and tools for using Tailwind and all kinds of fun stuff like that. So you can check that one out at baliata.dev. Today, though, to address this topic of logical concerns, I want to structure it by thinking about the what, why, and how. So we're going to talk about what does it mean to organize code by logical concern, why would we want to do that, and then how do we do that. And then toward the end, we're going to talk a little bit about pushing the limits and looking at what the next wave of code organization might look like with the composition API. So let's start with the what. For me, it comes down to the idea that options, in the options API, they're categories that describe what your code is. So when you have reactive references, you put them in the data category. When you have memoized values, you put them in the computed category. Functions go in the methods category, etc. And you have side effects for watchers and lifecycle hooks. Logical concerns, though, are categories that describe what your code does. So you can think of each feature in your component mapping to one logical concern. And then the tricky thing here is that concerns change for every function, every setup function, every composition function that you write. Every one is going to have different features, so every one is going to have different concerns. And there's also no limit. You can pack as many features as you really want into a single composition function if you can find a way to tie them all together. So yeah, the difference there is that but with components written with options API, the categories are consistent in number and in type, but with logical concerns, the categories are much more fluid and they change much more dynamically from component to component. So that's the way that I like to think about what these things actually are. Options describe what your code is, and logical concerns describe what your code does. So let's tackle the why. Why would we organize by options and why would we organize by logical concerns? And I think the best way to answer this question is to use my beautifully scientific drawings of this graph of WTFs over time. And some of you might be familiar with WTFs over time as like what the Fs over time, which is kind of like a measure of how understandable your code is. How many times do people have to ask themselves that question when they're reading your code? But for me, the more important one here is where the F's over time. So when we're writing an options API component, how many times are we asking ourselves, where is this piece of code supposed to go? And with options API, in my very rigorous scientific experiment, I found that you don't really ask that question a lot up front when you're first writing, like the first wave of code. After a few components with Vue, you get kind of an intuitive feel. When you have a piece of code in your head, you kind of know, oh, this is going to go in the data category, or this is going to go in the methods category. So there's fewer where the F's initially. Over time, though, as you continue to return to and expand this component and refactor it and bug fix it, the count just kind of steadily grows. Because every time you come back, each section is larger, there's more scrolling around to find the pieces that you need to edit or refactor, and the problem only gets more complicated as you pack more features into a single component. With logical concerns, though, The WTF count at the beginning is pretty high because you don't really know offhand what the logical concerns are. You're still trying to kind of figure out what features this component's going to be responsible for. What are the lines we can draw between those individual features for our code organization? So the WTF count at the beginning is pretty high. You're very often asking yourself, where is this piece of code supposed to go? And you're not exactly sure. Over time, though, once you have that initial wave done, the count stays pretty low. And we can flip back to these screenshots too to illustrate that. So when you return to a composition API component that's organized by logical concern, when you go to refactor a certain feature, let's say we're in this green section, pretty much all the code you need to touch is going to be in this green section. It's almost guaranteed in my experience that you're never going to touch another section when you're working on a different one. So the code in here is tightly coupled. It gets written together. It changes together. And then if you want to add a new feature, all you do is just come down to the bottom of your function, because we're just working in free-form JavaScript functions at this point. And you just add a new section at the bottom, and you can be confident that that code doesn't need to touch anything else in the rest of the component. There are exceptions, of course, but in my experience, 90% of the time, you can follow that rule. So plenty of where the F's initially when you're writing with logical concerns, but over time, the count stays low. So what's missing from here? I don't think I've presented so far a lot of information that is particularly new to our Vue ecosystem. Maybe I've just kind of expanded and articulated some ideas that we've been talking about since it was launched. But I think what we haven't talked about much is how do we actually do this? What are the rules of thumb that we can follow so that when we're refactoring, we get a smooth transition from the options API over to the composition API organized by logical concern, and we don't get stuck in this midpoint where we have kind of mixed organization of our code and things are kind of half composition API, half still constrained by options. And we enter a component not knowing where to find something. So how do we actually avoid that issue? And to illustrate that point, I've actually written all three of these components. So these three screenshots, these are three real-world implementations of a custom drop-down list box kind of thing that I wrote. It's all the exact same code, just refactored in three different styles. And here are the live demos of those components. So they've all got the same feature set, and we'll just explore it briefly right now. So when I hover over one of these lists, you can see that it's getting highlighted. I can click on that option as well to select it. It's kind of the very basics of how a list box should work. Also, when I'm hovering over these items, they're not just getting highlighted, they're receiving focus. So I can now use my keyboard to navigate the list box as well. So I've got up and down arrow key handlers, command up and command down so I can jump around. And then of course I have enter and space to handle item selection. And yeah, the feature set, like I said, the code is identical across all three of these components. The only thing that changes here is the code organization. So we're going to look at that right now. I'm going to flip over to the VS Code here. And let's just start by looking at the templates of these three components. I'm tabbing through VS Code right now. You can see the templates are all exactly the same. And we'll briefly touch on what's going on here. So we have a bunch of LI elements rendered in a list by v4. We're iterating over options here. The idea is that we'd pass in these options, an array of strings, as a prop to the component. The key is the option, which is a string. Tab index, this is kind of an interesting binding. If the item is selected, we are passing 0, otherwise -1. This gives us the feature that when you tab into the list box, the selected item gets focused automatically. We're not going to go through all of this stuff exhaustively, but just know that there's keyboard and mouse handlers here for activating different items and for selecting different items. And then there's this little piece right at the bottom. This is a feature in Vue called function refs. We can bind a function to the ref attribute of an element, and it's just a way of getting access to the elements when they're in the DOM. We are going to store those elements, and then we're going to use them later on to programmatically focus different list items as the active item changes. So again, I don't really want to dive into this all exhaustively. This code I'm publishing in the talk notes at talks.alexvipond.dev, so feel free to pop over there and check out the code in more detail. But right now, let's just take a look at code organization and get a feel for how these things look, and we can compare and contrast the three versions. So We'll skip over components and props for now, but let's check out. We start with data and some computed here as well. So we have 2 items of reactive data defined. The active index, where we track which item is active, and then this elements array. This is where we store all of our list items so that we can reach into this array later on and grab a list item and then programmatically focus it. You'll see that happen in just a sec. So the computed item, we've got a sort of a computation of which item is selected. Then we have a bunch of methods for selecting different items based on their index, based on what position they're in the list. Activation, shortcuts for activating previous and next, and then a function down here at the end, the set elements function. This is where we actually grab the elements out of the DOM and store them in our elements array. Then we've got a watcher, which is, like I said before, it's reaching into the elements array, focusing the active item, and it's watching the active item. It's changing whenever that happens. So this focus side effect happens whenever we change the active item. Then we have a mounted lifecycle hook, and it checks the autofocus prop. And if that prop is true, it will do that programmatic focus side effect. So it'll focus the list item that's currently active when the component is first mounted. Then this before update hook is just kind of an implementation detail of how we're grabbing those list item elements out of the DOM and storing them. So yeah, pretty familiar, I think, if you've used Options API before. You have your data, your computed, your methods, your watchers, and your lifecycle hooks. I would never claim that I always wrote my Options API components in exactly this order, but I think over time I've gravitated more toward this idea where I start with data, then I move to computed, etc. Let's check out now the Composition API version of this one. So this, we're importing all of our Composition API tools here. And we have our data section where we've got our 2 pieces of data defined, our computed, we've got our methods. So this is all pretty much the exact same code in the exact same order. The only difference here is that we are in script setup inside of a Vue 3 component. So we're just kind of, there's no indentation. We're just kind of in freeform JavaScript. We could move these things around wherever we want without interrupting the component's normal features. But in this case, we are just organizing it exactly as if we were still using the Options API. So we've got lifecycle hooks down here at the bottom. So yeah, very similar structure between these two, between the Options API component and the Composition API component, the kind of Composition API components that I first started writing when I picked up the Composition API. I was pretty much always doing things this way, defining things in the same order and in the same organization patterns that I would if I was still in the Options API. Now for something quite different, the Composition API component. This is the refactored version, fully organized by logical concern. So we've got our tools again imported from the Vue Composition API, and we're scrolling down and just checking the sections, right? Not trying to get a deep sense for how this code works and why it works the way it does, but just keeping an eye out for how the code is organized and what sections we're working with. So we've got a section of code here to deal with this active item, to mutate this and track it over time. Then scrolling down further, we've got a smaller section to deal with the selected item. That's where we set up this computed prop, and we write a few different methods for working with that as well. And then down here in this elements section, this is where we write all the code that captures the list item elements from the DOM, and then also auto focuses them when appropriate, and also does the mounted lifecycle hook where we autofocus if that prop is true. And then the on before update hook where we clear out the elements array before every component update. Again, that's just kind of an implementation detail of how we are choosing to grab the elements out of the DOM in this case. So that is the basic overview of all 3 of those components, of kind of a rough idea of the code we're working with and how the organization changes. And you can explore that, as I said, freely later on. But right now, I want to talk about tactics. I want to talk about what we can learn from what we see changing between these 3 components. Hopefully give you a few rules of thumb that you can follow when you're doing your own refactoring from Options API to Composition API. So the first tip, and the one that probably has helped me more than any other, was a realization that I had that often when you're doing this refactoring, each individual data and computed property is the foundation of a separate logical concern, and you can safely create a section for each one in almost every component. So let's take a look. Let's just compare Options API and Composition API components to see that in action. So in the Options API, we have our 2 pieces of data, and we have our 1 computed prop. If we flip over to the Composition API version, we have our active section for that active prop, the selected section for that computed piece of information, and then the element section for those elements. And this component divides really nicely between those 3 features, where we've got kind of 3 separate logical concerns, 1 for each piece of data that we were tracking in the original component. This doesn't work every single time. Sometimes you'll have a computed piece of data that belongs in a section with another piece of data. But yeah, I'd say 80 to 90% of the time, you can make this assumption that each individual data and computed prop is going to become its own logical concern, its own section of your Composition API component. So the next tip is within your sections, start with your reactive state, then write your methods, and then write side effects. Kind of echoing the original order that I was using here in the Options API component, where I started with reactive data, then I wrote methods, and then I wrote side effects, watchers and lifecycle hooks, things that need to be timed. So in the Composition API component, we can see that in action. In the active section here, we've got the reactive data defined first, then our methods. In the selected section, reactive data first, and then methods. And then in the element section, we've got a bit more variety to look at here. So we have our reactive data first, then a method, and then our side effects. None of this stuff is strictly necessary. And in a smaller component, maybe this won't matter. But for larger components, having these kind of rules of thumb and these consistent strategies for organizing code just makes your code so much more predictable in the long run. And the reason that I like to do it in this order is that it gives you kind of a nice gradient of complexity. So you start with the piece of data, which is usually the least complex thing. Then you introduce some methods, which do maybe some more complex actions with that data. And then you introduce side effects, which are pretty complex because they usually have to have a specific timing. And there's a risk that they might interfere with other things that other components are doing. So I like to have those last so I can get all my reactive data and other pieces in place before I try and worry about those side effects and making them work properly. So next tip is avoid the temptation to mix concerns inside watchers, lifecycle hooks, and event handlers. This is a trap that I fell into probably longer than any other. And probably best if we explain this with a little example. So imagine in this component, we wanted to pull the selected value from local storage when the component is mounted. And you already have a mounted hook booted up here. So it's tempting to just come in here and say select and then pull that value out of local storage and do that here. The issue now is that you have this one little piece of code that's clearly only related to the selected item, but it's tucked away inside of this section that's dealing only with elements. And the only reason you tucked it in there is because you had the mounted hook already. And this is definitely just like a reflex of working in the Options API that I had for a long time, where I would just go look for my existing watchers or my existing lifecycle hooks and just kind of pile more code into them, forget all my rules about logical concerns and organization, and just put stuff in there. And again, the effect, right, is that my code becomes less predictable. When I go into a file, I don't know where to find things or where to make bug fixes and stuff. So better in these cases to resist that temptation, and you absolutely have the power to make multiple lifecycle hooks and just put your code in there and keep it all in the right section. So that's something to watch out for. I'd say it's trickier with event handlers because you kind of have the temptation to make only one key down handler or something like that. But yeah, as often as possible, try and resist that temptation. Try and use the freedom of the Composition API to keep your code separate and keep it organized. Above all these things, just be consistent. I have no issues with the way that we organize code in the Options API. I did it for a long time and felt confident in the code that I wrote. So if you want to go for this kind of in-between solution where you're using the Composition API so that you don't have to reference this or deal with some of the other downsides of Options component structure, but you still like keeping your code organized that way, absolutely go for it. As long as you're consistent, and if you come back and add a new feature, you're careful to weave it into the existing structure that you have here, definitely go for it. The goal here is code predictability. The goal is not, logical concerns just for the sake of logical concerns. So as long as you feel like your code is predictable and you can find what you need, just stay consistent and follow your rules. For me, I've felt more successful and more organized when I put things into categories by logical concern. But the most important thing is just to be consistent with whatever strategy you pick. So those are kind of the main tactics, but I wanted to touch on one bonus idea, which is to organize template-related code by logical concern as well. And if we flip back to one of these components, the big error here, or the glaring kind of inconsistency, is that we have all of our code nicely organized by logical concern, except all of this stuff up here that's bound to the element. So we've got some activation code here, some selection code here. All of these things are far away from and separated from the sections where all the other work is happening. So I've been working on some different tools to do this kind of work inside of composition functions. Recreate vbind, recreate von inside of composition functions. And let's take a look at that right now. So I've got this fourth bonus list box. Again, all the exact same the features that you saw before. So arrow key handlers, enter and space, hover and click to select, all the same features. But if you look at the template for this one, it's very sparse, very minimal. All those listeners and all those bindings are gone. And the way that I did that was by using these two functions that I wrote. I published them in this package called Baliata Vue Features, part of that Baliata project that I mentioned before. And we have implementations of vbind and von that you can use inside of composition functions. So let's take a look at what that looks like. Here we've got our elements section, nothing going on in here, but in the selected section, remember we wanted to bind that tab index value. We wanted to make only the selected item have a tab index of 0. And I'm not going to, exhaustively go through the syntax and API here, but I've called bind from within a composition function or a setup function. And I set it up so that the tab index is 0 for the selected item and -1 for every other item. And so now this selection related code is in the same section as all the rest of my selection code. I've got some event listeners here using my on function, which is the recreation of von. So I can pass in some elements that I want to attach listeners to, and then I can just sort of set up an object that describes my listeners. And similar with the active item, I've got down here the on function setting up all of the different key combinations and different keyboard effects and mouse effects that I want to have happen. So this, I could do a whole other talk on how these things work and how to use them, but just wanted to show off the idea, kind of pushing the limits of what we can organize by logical concern. Just present the idea that it is possible to take code out of the template that is kind of disorganized within the template, makes the template messier and harder to read, make the template more sparse, and move that code down where it actually belongs in the sections of other logical concerns that it's related to. So yeah, that's kind of the last thing I wanted to present. You can find the talk notes for this talk at talks.alexvipond.dev. Feel free to send me a DM or tweet at me at alpalvipond. And then in the talk notes, just a few little extra bonus things here. New ebook that I've been working on called Rethinking Reusability in Vue expands on this talk's ideas. Some of these talk's ideas are included in that book. Link to the Git repo for all the code in this talk, live copy of the slideshow, including listbox demos, and then links to videos on related concepts like that function ref thing we were looking at before for capturing elements from the DOM and storing them. So some really fun stuff in there to look through, and I hope you have questions because I'm excited to talk about this stuff. And thanks so much.